The highest spot on Earth is not Mount Everest. It's something else. What is it?
To the astrophysicist, we don't really care much about sea level. You want to be high, you're measuring your distance from the center of the Earth. So you want to find the farthest point from that center. And it turns out sea level at the equator is farther away from the center of the Earth than sea level near the poles. Because Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere, it's oblate. So it turns out the pear-shapedness is bigger than the height of Mount Everest above sea level. There's a 20,000-foot mountain in Ecuador, which is right, Ecuador is like near the equator, hence Ecuador. The summit of that mountain is 1 1/3 miles higher away from Earth's center than the summit of Mount Everest. Earth has been misrepresented to us by geologists. Because the globes that you buy, that you rub your fingers over and you feel the Himalayas and you feel the Rocky Mountains. No, these mountains are puny compared to the size of the Earth. You would not know they were there. If you were truly that size, some big cosmic giant lumbering through space, coming upon the Earth, rubbing your hand on it, the depth of the fingerprint mark, the depth of that would be greater than the entire range of distance from the Marianas Trench in the bottom of the Pacific to the top of Mount Everest. Therefore, you would close your eyes, rub your finger, you would not know whether you are on ocean, valley, mountain, or hill.
Well, it might be wet or dry. It might be,
Well, by how much wet? The depth of the ocean doesn't measure up to the depth of your fingerprint. That's my point. So we've been fed this misrepresentation of our own planet on the belief that, in fact, we have real surface features, but cosmically speaking, we're practically a perfect sphere.
There was a time when people believed that the heavens up there were the province of God, and whatever was going on in there was unknowable, and it would be basically sinful to find out. Newton comes along, and then everything changes.
Yeah, so you look up and the planets are going forward against the background stars and then backwards, and nobody understands it. And the fact that no one understands it is presented as evidence for the divinity of the heavens, because that is the handiwork of God, and we are mortal, and God is immortal and omniscient, and so we can't possibly know the mind of God. So you're just content just in your ignorance watching planets. There was some attempts at this with the geocentric epicycles and all of this, but it was well accepted that you'll never understand. Newton comes along, writes down equations of motion, equations of gravity, and kind of on a dare, he invents integral and differential calculus. Then he turned 26. This is why Isaac Newton is my man, okay? Just to make that clear.
Okay.
So he writes down these equations, and he can now demonstrate how, why, and where, and what the planets are doing. And so potent was his new theory of gravity that it worked for moons of Jupiter orbiting Jupiter, not just planets orbiting the sun. And this was the first indication, maybe this is not just a local truth, that maybe it applies across the universe. In fact, Newton was accused, Isaac, you've left nothing for God to do. And that's simultaneously a dig at him, but also quite a compliment, that he can actually understand the mind of God. The tenets of the Big Bang, that the universe started out small, hot, dense, where matter and energy were a primordial soup, where the forces of nature had merged. All of that is thoroughly supported by observations of this universe. If tomorrow you have a new idea about how the universe works, it's gonna enclose everything we've been talking about up to that moment. But our universe would have started with a Big Bang, okay? And our universe would have expanded from a dense, hot state, and it's been cooling ever since. That's observed, and that's real, and that's not going away. I wonder if the human intellect is sufficient to actually decode the full operations of this universe in which we live. We are an intelligent species because we defined ourselves that way. We don't have the benefit of another species to compare ourselves with, against whom we might fail miserably. And so when we compare ourselves to chimps, we sit up righteously and say, we have poetry and the Hubble telescope and philosophy, yet there's only 1% difference in our DNA. But then you'll say, what a difference that 1% makes. And I would say maybe that 1% DNA difference corresponds with an equally small difference in the intelligence between a chimp and humans. And you say, I can't believe that. No. Well, imagine some other species that visits us that's 1% along on that same scale, smarter than us. Consider, the smartest chimp does what our toddlers can do. And there's no way you will explain to a chimp, I'll have dinner ready at 6:30, can you pick up some juice on the way home? The simplest human thoughts are inconceivable to a chimp. And their talents are about what our toddlers can do. So let's get back to this 1% smarter alien that we've discovered. Corresponding this analogy, we now say, what would we look like to them? Well, they would roll Stephen Hawking forward after combing the human species, and they'd say, this one is slightly smarter than the rest because he can do astrophysics calculations in his head like little Timmy over here, who just came home from preschool. Oh, Timmy, you just composed 3 sonnets. Isn't that cute? Let's put it up on the refrigerator door. Oh, you just derived the fundamental law of calculus. Isn't that cute? Put it up on the refrigerator. Their simplest thoughts would transcend our deepest thoughts. And maybe to them, it is obvious what dark matter is and dark energy. Maybe to them, particles popping in and out of existence is a trivial exercise in their understanding of the multidimensional space-time continuum. And we are here groping at the sides of a wall, not knowing how tall, wide, or deep it is, because we have the limits of the human physiology evolved off the plains of Africa just to try to understand the entire universe. So I lose sleep on that question each night.
How would the sun die?
Oh, the sun, like any star, it will run out of fuel in its core, and it starts changing. It starts bloating and getting so large that it will engulf the orbit of Mercury and Venus and come very close to Earth. So imagine looking on the horizon and sunrise is half the sky. But there's another one, the Big Rip, that if the expansion of the universe accelerates at a continued rate and it goes unchecked, the universe will be expanding in 22 billion years. It'll be expanding faster than the fabric of space-time can keep up with it. And it'll just rip. And I'm terrified by this.
All matter and all energy that you know and love, all the photons of light, all the particles of matter, when you add it all up, it's 4% of the total energy budget of the universe.
If that much of everything is missing and comes with no explanation, and yet is plainly, apparently doing things, I mean, the reason that galaxies seems to hold their shape is because there's this invisible stuff that makes them do so.
Dark matter, for lack of a better word. We don't know what it is. It's a source of gravity whose origin we have no clue. Dark matter. So we call it dark matter, we don't even know if it's matter, but it's a source of gravity that exhibits itself in the cosmos. There's 6 times as much of that as there is ordinary matter. So that was our first encounter with total stupid ignorance. Then, 10 years ago, or 1998, it was published in 1998, we discovered 70% of the rest of the universe is this mysterious pressure operating opposite that of gravity that's making the expansion of the universe accelerate. We don't know what that is either. We call it dark energy. So you have dark matter and dark energy combined make up 97% of what's going on in the universe. We have no clue what either of those is composed of. Our computing power is growing rapidly. We create simulations of worlds. We have video games with characters that are inside the video game. Imagine a day where you can simulate a world so perfectly with life forms, humans, so well that you can recreate every single neurosynaptic thought you could have, but now you're in the simulation on the computer. And you don't have to have all the world existing there at all times. That might be an unrealistic amount of computing power. You just need
enough of the world that they see around them.
That they see around them. There's a flag that goes up in the programmer and they say, oh, need more Earth. So they put Earth beneath you while you can keep digging.
It's like the Truman Show. Maybe that's why we can't travel faster than the speed of light. Because if we could, we'd be able to get to another galaxy
before they could program
that galaxy.
Oh! So now that world evolves and they develop computing power.
Right.
And they say, we want to play video games.
So now we're going to make a world.
So then they make a world and they have sufficient computing power that they invent to create a whole universe within their computers.
Okay.
And then
they make a world.
And then they make a world all the way on down.
Right.
It could be hundreds, thousands, billions, close your eyes, throw a dart. Which of these universes are you going to land in? The first one that's real, or the gazillion that are not? Turns out anything that goes faster than sound will make a sonic boom. The crack of a whip is the tip of the whip moving faster than the speed of sound.
Oh, sweet.
It's a mini sonic boom. The material, as it flings forward, and you start retracting it before it fully flings forward. And the rapid change of direction there is the thing moving just faster than the speed of sound, and you hear a crack. So let's go back to Aristotle. Aristotle has like a huge modern fan club where he can do no wrong.
Right.
But in physics, almost everything he said was wrong. So if you read his writings, I'll paraphrase one of them. It's objects will fall at a rate proportion to how much mass they have. If something weighs 10 times as much, it should fall 10 times
as fast.
And everybody just agreed with that because testing an idea had to emerge as a thing to do.
It's so funny that we take the scientific method for granted.
So that's what people thought until Galileo said, let me test this.
Right.
Let me test whether things fall at the same rate. So in the Apollo mission, Apollo 15, it turns out, they had a hammer and they had a feather. So on the moon, he's got the hammer and he's got the feather.
Right.
And lets go of them, and they both drop at exactly the same rate. But what made it work is that there was no air.
Right.
So if you got some cavity or some room where you evacuate the air, you could do that
still
experiment
work here on Earth.
On Earth.
Right.
Okay, so you didn't need the moon to make that happen.
Right.
If Earth is ready to get vaporized by the sun,
right,
you need some ability to planet hop.
Right.
Because the sun will grow in size, the temperature of Earth's surface will get hotter and hotter and hotter. Time to move, folks. You pick up your luggage, you move to Mars, the next farther planet from the sun, okay? But the sun will also start to make Mars hot, so then you want to move farther out again. Then the sun will eventually die and no longer be a source of energy to any of us. Then you want to be able to star hop, find another solar system.
How long do you think we could make it?
Last I checked this is not my field of expertise.
Okay.
I'm just relying on what I've read. And last I remembered, the average life expectancy of a mammal species is several million years. So, and we've been around for several 100,000. So we should have a
long way to go.
We got a long way to go.
If we don't kill ourselves.
If we don't kill ourselves. And it might be that intelligence, as we've come to know it and understand it, is contraindicative because you invent something that you think is cool and it's the end of the world.
Damn.
I think it was Kurt Vonnegut who, in one of his novels, he said, I'm paraphrasing, this will be the last sentence ever spoken by humans. It'll be one scientist speaking to the other saying, let's try it the other way.
Oh God, yeah, that's funny.
So once you have the power over nature and the forces of nature are greater than you,
right,
or are ultimately greater than you, then you are wielding forces that can render your own extinction.